In this part, we will go deeper into JPostman and explore some important features. We will start with the request object, which is immutable, meaning the original request loaded from the Postman collection cannot be changed directly. Here we're using request builder.build-env. JPostman uses this builder call to create a resolved request with environment values applied. I will move this expression into a local variable, so it is easier to inspect and debug. First, I will update the executor call to use a new argument. Instead of resolving the request inline, I will define a local variable named resolved request. Then I will print both the original request and the resolved request, so we can compare the body before and after placeholder resolution. Now let's run the code using Ctrl plus F11. In the console output, we can see that the original request body remains unchanged and still contains unresolved placeholders. The resolved request created with build-env replaces those placeholders with values from the Postman environment JSON file. Let's review other request builder methods. We can manually customize the URL, headers, auth, and body. For each parameter step, we can use methods such as add, set, JSON, or map and end resolvers. Finally, we call build to create a new resolved request object with all changes applied. As a result of the execution, we can see that the request values were updated. The URL now uses the mapped base_URL placeholder. The query parameter was added. The username value was replaced, and the new age field was applied. The password placeholder was replaced with the value from the environment JSON file. Even though TestNG shows the test is passed, the API response returns status code 405, which means HTTP method not allowed. To properly validate the API result, we need to add an assertion that verifies the expected status code. I will remove the inline print call and store the execution result in a local response variable. Then I will import ApiResponse from JPostman and add a static import for TestNG assert equals. Finally, I will assert that the response status code is 200. The test now fails correctly when the status code is wrong, and the assertion message includes the server response for debugging. I removed the hard-coded request customizations and cleaned up the code. Now, let's run the test one more time. The TestNG result is passed, which confirms that the REST API server returned status code 200 as expected. Before selecting another request, I will create a local reference to the Postman collection. This makes the code cleaner because I can reuse the same collection variable for multiple GET-REQUEST calls. I will import the JPostman collection class and create a local variable named kernel. This gives us a direct reference to the Postman collection loaded from the JSON file. Next, I will replace the direct CTX, that getCollection call, with a new call variable to make the code cleaner. At this point, I will let Eclipse clean up the source code. I will right-click anywhere in the editor, go to Source, and select Organize Imports. Then I will apply formatting. Now the imports are organized and the code is easier to read. I will also give the variable a better name. Since this request is used to get the token, I will rename REQ to REQ token. I will right-click the variable, choose Refactor, rename, and enter the new name. I will also apply the same refactoring step to the response variable. Since this response belongs to the token request, I will rename res to res token. Finally, I will simplify the code by removing the separate resolved request variable. I will move the .builder.build-env call to the end of the REQ token line, then press delete to remove the extra line. Since we removed the resolved request variable, Eclipse shows an error. Hover over resolved request and select change to REQ token from the quick fix menu. Let's call kernel print to display all available requests under the root collection again. Then press Ctrl plus F11 to run the test. For the next API call, we will use the getCurrentAuthUser. To save time, I will reuse the same 3 lines from the token request implementation. I will copy and paste them below the existing code, Then replace the request name with get current auth user from the console output. For the second request, I will rename the variable REQ token to REQ user, and I will change the response object from res token to res user. The first request passed, but the second request returns status code for 01 with the message access token is required. This means the request is missing an authorization value. The easiest way to debug this is to print the second request details, including the URL, headers, and body. For debugging, I will replace the collection print line with two print statements, one for the unresolved request and one for the resolved request. I want to execute the code only up to these lines, so I will set a breakpoint and run the test in debug mode from Eclipse. From the console output, we can see that the unresolved request expects the access token value. After resolving the request, this value is empty. To fix this, we have two options. Update the environment object so the value is available for all requests, or call the auth method only for this specific request. Now, I will remove the last breakpoint and clean up the temporary debug code. I will delete the temporary request print statements, then add restoken.print, so we can review the token response output one more time. The request returns an access token in the response body. We will use this token in the next request to build a chained request flow. I will replace execute with apply, so we can configure the executor before sending the request. Then I will use auth.oauth2 and pass the access token from the token response. Both requests return status code 200. In the next video, we will review best practices for organizing multiple requests in TestNG. Thank you for watching, and I'll see you in the next tutorial.